A constant volume calorimeter has a rigid container so it doesn't change volume. It's also called a bomb calorimeter. Because volume doesn't change and work is equal to pressure times the change in volume and volume 0, then work is 0. So delta E, or change in energy, is only equal to heat. So heat, or energy released, is equal to the change in temperature times the heat capacity of the calorimeter. That's the equation that you need to make sure that you know. Q equals delta T Cp. And that's the heat capacity of the calorimeter, not the substances in it. So here we're looking for hydrogen and methane's heat of combustion per gram. So first we're going to pull off all the information for methane. So we can ignore all of the hydrogen information. So our mass, if we look, is 1.5 grams. And it says the temperature increased by 7.3 degrees Celsius. And it says that we're in a bomb calorimeter. They gave us the heat capacity of the bomb calorimeter to be 11.3 kilojoules per degree Celsius. So we can plug that in to our equation, which was Q equals delta T Cp. So we don't need the mass yet. Solving for Q, that tells us how many kilojoules are released. But we want our answer in kilojoules per gram. So we need to divide this by how many grams of methane which were burned, which was 1.5. So we get 54.99 or 55.0 kilojoules per gram of methane. Go ahead and pause the video and do the exact same thing for hydrogen. So for hydrogen, you should have found that your mass was 1.15 grams. Your change in temperature was 14.3. And the Cp is still the same, 11.3. Divide that by our mass of hydrogen, and you get 140.5 or 141 kilojoules per gram. Always pay attention to the units that it wants its answer in. Go ahead and pause the video and try this one on your own. Restart when you have your answer. you should have gotten D for the correct answer. If you did, you can fast forward to the next problem. If not, follow along and see how we got D. We have a bomb calorimeter, so Q equals delta T Cp. They said the temperature increased 70 K, so that's our change in temperature. And we're looking for Cp, or the heat capacity of the calorimeter. We need to use stoichiometry to convert our 1 gram of octane to kilojoules based on the enthalpy of combustion. So you have to convert it to moles. And then 1 mole is going to release 10,920 kilojoules. Since we only burned 1 gram, converting should tell us how much energy was released when we burned that 1 gram. So Q is 95.8. We know delta T, so we can find Cp. Dividing those, you get D as in dog. Our units, kilojoules per Kelvin. I'm going to pause the video and try this one on your own. This is a limiting reaction type problem because they gave you grams of HCl and grams of NaOH. You'll need to convert both of them to delta T. So we're going to ignore the 0.22 grams of NaOH to start with and just work with the 0.2 grams of HCl. Just like the last problem, we need to find out what our Q, or how much heat will be released when we react 0.2 grams of HCl according to that equation above. So using stoichiometry, convert it to moles, and then use the enthalpy of reaction. So we have our Q. Now we can solve for delta T. Knowing the heat capacity of the calorimeter was 3.1. And you get 0.0955 degrees Celsius. But we need to do the exact same thing with our NaOH now. This gives us Q. Heat capacity is still the same. So our delta T for NaOH would be 0.0958. The smaller answer is the correct answer, like all limiting problems.